anything like organic. It's been generally on the like tone as we did now I values or
Okay, let's get started. Today is our last lab. So as you see, it's not an assignment, it's just a file. So please download Laboratory 31, and you don't need to submit this one after today's class. I only want to show you a demo about the classification model and help you to go through the projects, okay? So first of all, let's finish this lab first. Today I'm going to learn the classification model. And for the last few sessions, we talked about simple linear regression model or multiple linear regression model, right? But the classification model is a little bit different from the linear regression model, right? Because we use OLS, ordinary least squared methods, and MLE method to evaluate the models, right? We have some errors, but if we want to predict a descriptive variable, so it means, so here's the difference between the classification and the regression model, right? Because in the previous example, we want to predict something. We want to predict the average house value based on some features, right? We want to predict a number. We want to have a number based on some features, right? It is a linear regression model, and you see, it should be a regression line, and you need to measure the difference between the actual data and the predicted data to show how well your model fits the data set, right? But if you only want to know it is a yes or no, 0 or 1, not a number, means here you want to classify something into different parts. You need to use a classification model, okay? So here, regression problems has continuous and usually unbounded outputs when you estimate the salary, and but in this one, exactly you only need to choose usually 0 or 1, true or false, positive or negative, good or not, good or bad, right? So, and multi-class and other classifications, so this one, but usually it's a binary classification, means 0 or 1, good or not. Okay, let's see one concrete example. Logistic regression is it's a classification model, right? we need to write it. And actually you have already learned it in the lectures, right? Linear regression and logistic regression, right? Here is the difference. So it is an example. Please download the diabetes CSV file. And this one originated from some like official datasets. So you need to use this one to determine, predict whether or not a patient has diabetes. So let's have a look. So there are many columns, right? But the last one, you see the outcome would be only 0 or 1 is something you want to predict, right? Only 0, 1. 1 means it's positive, a patient has diabetes. 0 means not. So there's only 1 and 0. And there are many different features you want, many features you can analyze, right? So here you see consists of several medical predictors, variables, and target variable outcome. Outcome is only 1 or 0. So you see there, pregnant, and so many columns. You can check the columns, right? And one thing to notice is only the last one outcome, only 0 or 1, but for other columns, there are some concrete numbers, right? Other numbers. So that's why here is a binary classification model. You only want to know the outcome is 0 or 1, 0 or 1, right? Okay. So first of all, you need to import NumPy, Pandas, Matplotlib, sklearn, and Seaborn, right? To plot them. And you need to use Pandas read the CSV file to read the diabetes, and then you can rename the columns, right? It is a good way to rename it and show the first 5 rows for the head. And here you see the column names are new column names, right? It's easier for the readers to read. And you can also use the describe to show the 5 summary features about the data set. Okay, label, and label is the last one. Label is the outcome, right? It's only 0 or 1. So you can also check all the histograms on these different features. Histograms, right? Second one, the first one, second one, and set the label. Because in the label, there's only 2 value, only 0 or 1, right? So that's why here we can only use the beans as 2 because there's only 0 or 1. Okay, and you can also set the second column and then the label to show the like a fancy joint plot on that, right? So you will know, have a roughly idea about the relationships between the features and the outcome. Okay, so next one here, we need to select the feature. We need to select feature. We need to construct the classification model. So here we need to divide into different predictors and target variable, independent variable, features variable. You can call it the feature variables. So it means the first 8, 1, 2, 3, 4, 6, 7, 8. The first 8, they are all feature variables, and only the last one is target variables. It means the outcome, or you can call it a label. It's only 1 or 0, right? So you set it here as a feature columns, and set X as the features, Y as the target, and you can split the data. So that's the biggest difference in the classification model. Suppose we have like 768 rows, right? We need to split them together. We use a part of the data to train the model, and use the rest of the data as the testing model to test your models, to evaluate your models, okay? So here, to understand model performance, that dividing the data set into a training set and test strategy. So split the data by using the functions train, test, split. Features, target, and test the set size. It means it will random select some columns, some rows as the training data set, and use the rest of them as the testing data set, right? So here, if you set is 75, 20, 25, it means 75% of data will be used for the model training. Okay, so as you see here is import. You can use the model selection. sklearn is a basic machine learning package, right? sklearn import the train test data set, and the test size would be 0.25, right? You set is at X train, X test, Y train, Y test. It means if you use this way, this CSV file has been divided by 4 parts, right? Some of them, they are X train. It means the training, testing, the training features, and the training outcomes, and testing features, testing outcomes. Okay. Run it, please. Okay, so and after that, you can use the X train, X test, Y train, Y test to train a model. Okay, so any questions so far? Okay, next one is how to initialize your model and how to train your model. Okay, so first of all, you need to import logistic regression model, create a classifier object, use a function, and fit your model on your train set. So first one, you need to import the class, right? Import sklearn and import logistic regression and initialize it. And here you need to set the how many iterations you want to have. So here you can set 1,000 or 10,000, it doesn't matter, because for now your training data set is not very large. If it is large, you need to set larger iterations, okay? And it is a variable name about of this logistic regression model, and you can use the training data sets to fit it. X train, Y train to fit the model, and after that you can import X test to predict something, to predict the outcome with this logistic model. Okay. So when you run it, and now it is your multiple regression model. Oh, but not a multiple regression model. It's logistic regression model. And then it is predicted for X test, and they are all 0 or 1, right? But here, for now, you have this model, but perhaps it's not the best model because in the Y test, right? Here, Y test, you have already known for X test, it should be 0 or 1, right? And here they are predicted data, so in some cases they are different. Then it is an error, right? So that's why we need to evaluate the performance of the logistic regression. So you need to check the difference between the predicted Y and the Y test. Okay, that's why we need to split them into 2 different parts. So for this one here, we have 4 different kinds of results: true negatives, predicted negatives, true positives, and false negatives, and false positives. So they're different, right? And actually, you don't need to write them together. You don't need to write your own functions. You can just call some functions from sklearn, right? From sklearn here, you can also import a matrix and use a confusion matrix to show that array, right? So here in this one, this is a true positive, And the second one is true positive, false positive, true negative, false negative. Okay, so it's about the it's true positive and true positive and true negative, and the false positive and true negative. So yeah, it's about the confusion matrix. You can use this one to evaluate your performance. Right here we have the confusion matrix, and in this output, I think it's a little bit different because here, because your models every time you train your model, you use randomly selected training DSS, so the result would be a little bit different. For instance, here this one would be 117, and true positive and true negative and the 36 are actual predictions, and they are incorrect predictions. This one and this one is 26 and 13, not 11 in my model, but in your own model it will be different. Okay, and next one, when you need to visualizing confusion matrix using heat map. Okay, and you can use this way. You can learn from it here to use a subplots to plot them and set different ticks, and use a heat map, right? Seaborn heat map, and right, and you see here true positive, true negative, false positive, and false negative. And you can also because you have already learned the currency precision, recall F1 score of them, you can also use them to use these functions from the matrix class to test them, and you can also report them if it's good or not. And actually it is pretty good, right? Because the currency and precision, they are they are pretty large. Okay, so yeah, and in this way, this is something you want to predict. It is a model, but more importantly, you need to evaluate your model using this confusion matrix and this F score or precision or accuracy or recall. Okay, it's about how to initialize, how to train your logistic regression model, or you can call it a binary classification model, and how to evaluate the performance. Okay, so any questions so far? Okay, and it is about the laboratory 31, and no exercise, and you don't need to submit this one. And I received many emails about this RIDE1 quality projects, and have a look. You have already gone through that, right? So I only tell you about the tasks. So first one, you need to read some reviews, have some literature study, and then download the data set. You can use the request, and you can also just download it manually and exploratory data analysis to get the informations, making some plots, and modify the DSS. Perhaps you need to rename it or something. And next one is about the classification model. Okay, so it's very important. So here you need to implement a classification algorithm from scratch to classify good or bad ones, right? So it's just what I said today. In this one, it is used to show it is 0 or 1, true or false, positive or negative, good or not. Okay, so that's why here you need to use the classification. You need to use sklearn. Sorry, this one sklearn. Use a logistic regression model to solve this question. Okay, and please make sure to evaluate your model. For perhaps you need to use a confusion matrix. You need to calculate all these scores to evaluate this classification model if you choose this project, okay? And you need to if you're not sure how to do that, you can check the codes from Laboratory 31. All right. Okay, so it is about this one, but for the other three, I think let me go through it from the first one. From this one, you see tasks, they are similar, right? From the tasks. So first of all, you need to do some literary study, read something, and download the dataset, right? And then describe the database, use the describe method, and reformat the column headings. You already learned how to use that, right? Describe is just use this method, and rename, you can use this way to rename it, okay? All right. Describe and rename and build a data model and access the data model. So in this way, it's a little bit different. So it's not a classification model. It's you want to predict something. You want to based on the features, give a predicted value. So you need to use a regression model. Okay. So in this way, you need to use a regression model to find a regression line to predict something based on your features. So here you need to build it. And for access the data model quality, so in this way you can use the RMSE or R squared to show that R squared score to show how well it fits the data, it fits your actual data, and build a data phase using for your model. So it means you need to define a function to import some arguments. For instance, here, if you have these features, pass these features to this interface, to your functions, and then give a, and after that you can predict the strings or predict something you want. Okay, it is about this model. The first one is it is a regression model. Okay, and the next one, instruments, is similar, I think, but a little bit, it's more complicated, right? So here, literary study, summarize and download the data, analyze the data, and build another model. It's a little bit different because here there are more parameters, right? So you need to you need to have multiple plots. You need to figure out the relationships between the features and the results. Okay, so but if you are not familiar how to do that, you can check the codes from Laboratory 28, 29, and 30. Okay, and build the interface is similar. So you need to define a function and pass this pass some parameters or arguments to use your function, to use the model you trained. Okay, and after that you need to have some concrete numbers and use your model to predict the outputs with these numbers. Okay, it is about the second one, and power consumption. And in this one, it's a little bit different. It's also a regression model, but you see here, you have three important features and 3 outputs. So you need to actually you need to define 3 models, I think, right? So literary study, and download them, explore them, describe, and make some figures, and then build 3 models to fit the power consumption for 3 zones. Okay, so which inputs strongly affect the power. So actually, if you check lab 30, so far it's lab 30, let me show you. So here means because you see there are 3 important: temperature, humidity, and wind speed. There are 3 features, okay, and then in lab 30, we learned, right? We can use this way, right? Correlation map to show which one has a strong relationships between the features and the outcomes. This one, right? Because first we build a multiple variable model. We consider all the features, but most of them, they are very, very small. They are pretty small, right? So next one, we select some usable variables and build a better model with only 3 columns because they are closely related to the outcomes, okay? And the power consumption. So here you need to determine which one is strongly affected the power and build the 3 models because there are 3 different outcomes. And then please build a function to be the interface to take the inputs or arguments and use that to perform some experiments to evaluate the performance. Okay. All right. So I think that's all about the projects and the labs. Okay. So any questions? Okay, so I will upload the recordings to YouTube. So if you are not familiar about some projects, you can view the videos again. All right, so yeah, thank you guys, and that's all I want to share today. And if you have further questions, you can send me an email. All right, so you are free to leave. And thank you so much. Have a nice day.